as we've been working on solving equations with radicals, as we've cleared those radicals, we have seen linear equations once we do that. Sometimes we end up with quadratic equations. So this is going to pull on your memory of factoring and how you solve quadratic equations. So we're going to combine these two different ideas here. So first one, we're going to solve u equals the square root of 8u minus 12. So let's start by solving this. So what you might notice is that we have a radical in it, and it's isolated already. So we can jump right into squaring both sides. I want to clear that radical. So I'm going to square both sides. On the left side, I have u squared, and on the right side, my square cancels the radical, leaving me just what is inside, 8u minus 12. Well, now we have no more radical, but we do have a quadratic because we have our variable squared. When we're solving quadratics, as you hopefully remember before, we have to set it equal to 0 and then factor. Always, when you're doing this, when you're trying to set it equal to 0, keep your squared term positive. If you try to subtract u squared and move it over here, you end up with a negative leading coefficient, and that just doesn't work out well. So what we're going to do instead is we're going to move these two terms. We're going to subtract 8u and add 12. And over here on the left, subtract 8u and add 12. And what we'll see is we have u squared minus 8u plus 12 equals, and this is all gone. So we have 0. Don't forget to put the equals 0. How do we solve this now? We have to factor this quadratic. It's a second degree trinomial with a leading coefficient of 1. So we're going to factor it by finding two numbers that multiply to be 12 and add to be negative 8. And we're going to write them as u minus 6 and u minus 2. Negative 6, negative 2, multiply to be 12, add to be negative 8. They still equal 0, but we're not done. We have to solve this still. So we take both of these binomial factors, and we write them as u minus 6 equals 0, u minus 2 equals 0, and then solve them both to get u equals 6 and u equals 2. So we have two solutions. But as we've learned about equations with radicals, we always have to check them. So we go back to our original equation, and we have to check both. Our original equation was u equals the square root of 8u minus 12. So let's check 6 first of all. 6 equals the square root of 8 times 6 minus 12. Does 6, I'm really asking a question, does 6 equal the square root of 48 minus 12, which is the square root of 36? Yeah, that checks out. Yay, 6 is a solution. Now we're going to check the 2. 2 is equal to the square root of 8 times 2 minus 12. 2 is equal to the square root of 16 minus 12. And you can see it's probably going to work. 2 is equal to the square root of 4. And yes, 2 equals 2. That checks out. So this checks out. For this one, we have two solutions. Okay? Let's try another one. Next one. Let's solve the square root of negative x plus 23 is equal to x minus 3. All right. So we scan it. We observe it first. We notice that we've got this radical over here, and we want to get rid of it. It's already isolated, so we can square both sides. Again, don't try to square these terms individually. We're going to have to square this entire binomial. On the left-hand side, the squared cancels out the root, and we have negative x plus 23 equals, over here, we have to write this binomial twice, and we're going to have to distribute. I'll rewrite the left term, or the left side of the equation, and we have to distribute. Binomial distribution, x squared minus 3x plus 9, right? -3 times -3. Let's keep cleaning up the right side before we go any further. X squared minus 6x. These are both negative, so it's going to be minus 6x plus 9. We notice again we have a quadratic equation, and so we're going to have to factor it, but first we have to set it equal to 0. So we're going to turn this left side into 0, do the opposite of both of these. So we're going to add x here, we're going to subtract 23 here. Over here, we're just left with a big old 0. On the right, x squared minus 5x minus, what's that going to be? 14. We finish it up by factoring this. X minus 7 times x plus 2 is equal to 0. -7 times +2 multiplies to be -14 and adds to be -5. And then we set both of those binomial factors equal to 0 and solve them. So we get 7 is equal to x. So there's one solution. And -2 is equal to x. There's our other solution. What do? We check them. For the sake of time, I'm not going to check both of them because you know how that works. But I am going to tell you that -2 does not work as a solution, and I'll show you why. The square root of -x plus 23. So this is like -2 plus 23 is equal to x minus 3, -2 minus 3. Inside, we have +2 plus 23 is equal to, over here, -5. And you can already see why it's not going to work, I think. The square root of 25 is equal to -5. 5 is equal to -5. And we're always just asking this question, is this true? We get down to here and we say, no, it is not true, which means -2 does not work. I suggest you check the 7 on your own and confirm that it does work. One more of these. So we're going to solve the square root of 7x plus 22 minus the square root of x plus 19 equals 3. So this one also is a bit complicated. It's going to take a bit of work. You'll notice we have two radicals. They're not isolated yet. So I'm going to isolate this one. I'm going to add the square root of x plus 19 to both sides. We then have the square root of 7x plus 22. I'm going to bring my equal sign over here a little bit. This cancels out. Here we have 3 plus the square root of x plus 19. This thing plus this thing. We can't combine them. They're not like terms. We have to leave them separate. We've isolated one of our radicals, so we can now square both sides. On the left side, we have 7x plus 22, because the square cancels out the radical. On the right side, it's going to get messy. I'm warning you. So we have to write this out twice. 3 plus the square root of x plus 19 times 3 plus the square root of x plus 19. And we're going to have to distribute, binomial distribution here. So let's do it. Leaving this side alone, 7x plus 22. Again, when you're doing these, pause these videos, stop, re-listen as you need to. So we're going to distribute 3 times 3, which is 9. And then 3 times the square root of x plus 19, which is just that, 3 times the square root of x plus 19. Then we're going to distribute this radical right here, this times the 3. And we're always going to put the 3 first in front, 3 radical x plus 19. Now here, be careful. We have the square root of x plus 19 times the square root of x plus 19. Whenever that happens, the radicals are just going to cancel each other out, and you're going to be left with x plus 19, okay? So you're just going to be left with the inner part of that radical. Let's clean some stuff up. So I'm going to leave this alone for now. And on the right side, I've got a 9 and a 19 that I can add. So that's 28. I've got these two radical terms. They're the same, right? They've got like radicands. So that's going to be plus 6 times the square root of x plus 19, right? We just add those coefficients. And then we've got this plus x hanging out over here. Well, we ran into this in a previous video where we eliminated one radical, but when we still have another. So we're going to have to square all this stuff again. But first, we have to isolate that radical. So let's subtract 28 from both sides and also subtract this x from both sides. That's going to allow this thing to be all by itself. So when we do that, on the left, we're going to have 6x minus 6 equals, this is gone and this is gone, 6 radical x plus 19. Now, there's actually one more thing we can do here to clean this up before we go any further. We can clear this x. We can divide this by 6, and we can divide this by 6, okay? Because this has two terms, you can never cancel part of a binomial. This 6 belongs to both of those terms, so we actually have to cancel it from both of them. So this 6 and that 6 both are going to cancel out. That one, we're left with x minus 1, right? This 6 will cancel to just be 1. X minus 1 equals the square root of x plus 19. These cancel out. If you're confused about this one over here, here's another way to think about it. 6x minus 6 over 6. We could factor out a 6 from the top, a GCF, and write it as 6 times the quantity x minus 1 all over 6. These cancel, and you're just left with the x minus 1. That's another way to think about that too. Well, this is starting to look a little bit better, but we still have to clear this radical. So we're going to square both sides again. Basically, for the second time in this problem, we're squaring both sides. On the left side, again, we have a binomial. So we're going to have to do binomial distribution again. On the right side, they cancel out. So we're just left with x plus 19. That's good. We have no more radicals. This distribution is going to be x squared minus x plus 1. You can check that distribution on your own. And then we have x plus 19. On the left, we've got x squared minus 2x from these two, plus 1 equals x plus 19. Then we're going to move all of these things out of there. We have a quadratic again, and so we're going to have to factor it again, which means set it equal to 0. So I'm going to subtract x from both sides, subtract 19 from both sides. We have x squared minus 3x minus 18 equals 0. Factor. Find two binomials about x minus 6 and x plus 3 equals 0. Negative 6 times 3 is 18, negative 18, and they add to be this, negative 3. Solve both of these small linear equations, right? Take both binomial factors and set them equal to 0. So we end up with x equals 6 and x equals negative 3. But what do we always have to do? We have to check them. I will tell you right now, 6 works, but negative 3 does not. And I'll show it to you. I'll show you why. It's important to see why. We have to go way back up here. So I'm going to check it down here on the right. So we have the square root of 7x plus 22 minus the square root of x plus 19 equals 3. So let's substitute in for x that solution that I said didn't work, which was negative 3. So we have the square root of 7 times negative 3 plus 22 minus the square root of negative 3 plus 16 is equal to 3. In this first one, we have the square root of negative 21 plus 22. And then in the second one, negative 3 plus 16 is the square root of, I'm sorry, I got a little ahead of myself. I did the subtraction. This one right here should have been the square root of negative 3 plus 19. I started to do the subtraction already. Negative 3 plus 19 is 16 equals 3. Okay. Negative 21 plus 22 is 1. The square root of 16 is 4. The square root of 1 is 1. 1 minus 4, is that equal to 3? It is not. We end up with negative 3 equals negative 3, which is false, not true, which proves that x equals negative 3 is not a solution. But as you should go back and do, check that 6 is a solution. So just to recap, we are working with radical equations with quadratics. Sometimes they're fairly simple. You square both sides, you end up with a quadratic. You have to set it equal to 0 and factor. Other times it takes a little bit more work. You have to square both sides and then square both sides again. And if you end up with a quadratic, remember you do have to factor that, solve, check.